In this short video, I'm going to walk through how to find an annualized rate of inflation. We're going to start by looking at a very simple equation. To solve equations algebraically, we're always doing inverse operations. I think we know this, that the opposite of plus 5 is minus 5. So if I want to isolate for x, I've got to do the inverse to both sides, and I have x equals 16. Same thing, if I had x squared was equal to 16, I want to do the inverse operation to isolate x. Well, what's the inverse of squared? Well, it's square root. We've probably known this from doing the Pythagorean theorem. The opposite of squared is square root, so x would be equal to 4. Here's just one more, a little bit different. I've got x to the power of 5 is equal to 19. Well, what's the inverse operation of 2 to the power of 5? Well, if it's squared, the opposite is the square root. So the opposite of x to the power of 5 is going to be the fifth root of x. And we notate that, that's my fifth root. So square root, we normally write like that, but technically I could also add a 2 and say, look, that's my square root. So here's my fifth root of 19. How do I find the fifth root of 19? Well, it turns out it's definitely not a whole number. There's no whole number raised to the power of 5 that equals 19. But every scientific calculator has a fifth root button. So I'm just going to show you on two different calculators, and hopefully yours is somewhat similar. If I want to use any of these buttons, but get to the text written above the button, I'm going to use my shift key. On some calculators it's shift, on others it's second. So as soon as I press shift, I'm now using all these buttons, but instead of what's written on them, I'm going to use the function written above the button. So in this case, I want to use that nth root, or that x root button. So I'm going to press shift. If I want to do the fifth root, I'm going to press 5. Then I'm going to press shift. Okay, so that's the fifth root of 19, which could maybe round to 1.8. So I could have x equals 1.8. So you have an nth root button on this calculator. Same thing with this one. So I'm going to press 5 first if I want the fifth root. Then I'm going to press second. It's the opposite of power, so it's actually written above the power button. The fifth root of 19, again, is 1.8. So scientific calculators should all be able to do the nth root. And that's going to be important as we start trying to figure out the annualized rate of inflation. So let's look at a Big Mac hamburger. This video is not sponsored by McDonald's, although I would take their sponsorship. This is roughly true. It cost $2.50 for a Big Mac in 1995, but that had raised to $4 in 2003. You can post in the comments what a Big Mac costs now. So how much had that Big Mac price increase over those 8 years? Well, pretty clearly, to find the difference of the increase, I would just subtract the new price minus the old price, so it increased by $1.50 for minus 250. Out of the percentage, I would divide by the original price. This is my formula for percentage increase. It's going to be new minus old divided by old. So in this case, I get $1.50 divided by $2.50, which works out to be 0.6. So that Big Mac price, unfortunately, if you like Big Macs, increased by 60% over that 8-year period. So how do we figure out its annual inflation rate? How much did it go up by each year on average? It's not as simple as just doing 60 divided by 8, because inflation compounds. So I don't actually need to increase, what is 60 divided by 8? 7.5%. It's not going to go up by 7.5% each year, because that compounding effect will actually make the price go up way more than just 60%. So instead, we can use our compound interest formula and apply it to calculate the rate of inflation. So that formula means my future price equals my present price times 1 plus the inflation rate, and then n would be the number of years. So I'm kind of using the same formula. So my future price, or my new price of the Big Mac, is $4. That current price is $2.50 or $2.50. And I want to figure out what's my inflation rate that compounds 8 times to get my new price of $4. So I want to solve this equation for I. So like always when we're solving equations, I want to do inverse operations to isolate I by itself. When I'm done this question, I'm going to figure out what is my inflation rate I. So my first step is I want to get rid of this coefficient of 2.5. So I'm going to divide both sides by 250. So I can do that on my calculator if I want, and I get 1.6 equals 1 plus I to the power of 8. Now if I want to isolate for I need to get rid of this exponent by doing the opposite or the inverse operation. the opposite of 2 to the power of 8 is going to be my 8th root of the left side, will just equal 1 plus I. So there I got to use my nth root button. I'll show you on my calculator. I'm going to press 8, shift to the power of, which will get me my nth root button, so the 8th root of 1.6, I get 1.0605. So I'll just round that to 1.06 equals 1 plus I. And then to isolate I can just subtract 1 from both sides, so my annual inflation rate is 0.06, or if we want to express as a decimal, that would be 6% inflation. So if it compounds 6% each year for 8 years, that price would rise from $2.50 to $4. So that's how you can use inverse operations and this new nth root function on your calculator to find an annual rate of inflation. Okay, thanks for watching.